Beta decay equations by KayScience.com. I'm now drawing the nucleus of an iodine 131 nucleus, whereby the nucleus of this iodine atom has got a relative atomic mass of 131 and an atomic number of 53. The number of protons is the bottom number, the atomic number, which is 53. And if the number of protons is 53, that means that the number of electrons in an uncharged atom is also going to be 53. Well, the number of neutrons is the relative atomic mass minus the atomic number. So you're going to do 131 minus 53. That will give you the number of neutrons as 78. We're now going to look at beta decay. So let's look at a neutron inside the nucleus. The neutron has not left the nucleus, but all I'm doing here is visualizing one neutron in the nucleus. So inside the nucleus of this iodine 131 atom, there are too many neutrons. That means that a neutron is going to change into a proton and an electron. So the neutron is going to change into one positively charged proton and one negatively charged electron. The neutron turns into a proton and an electron, and that electron is immediately emitted from the nucleus. And this electron is emitted as a beta particle. So a beta particle is an electron. It's question time. Attempt these questions to check your understanding. And this is how we represent a beta particle. The beta symbol with a 0 and a -1. Let's now look at what happens to the number of protons, electrons, and neutrons in the nucleus during and after beta decay. So we started off with an iodine 131 nucleus with the number of neutrons as 78, but remember, we are going to have the neutron number decrease by 1. So you're going to go from 78 neutrons to 77 neutrons. It's question time. Attempt these questions to check your understanding. And before the beta decay, we had 53 protons. But remember, the neutron has changed into a proton and an electron, and that proton remains in the nucleus. So the number of protons goes from 53 plus 1 proton now has 54 protons in the nucleus. However, the number of electrons orbiting the nucleus in the shells still remained as 53. This is because the electron that is emitted is not emitted from the orbiting shells. It is emitted from the nucleus of the atom that is a beta particle. But the charge does change. If you've got 53 electrons and 54 protons, you've now got a positively charged atom. Let's now show that the relative atomic mass does not change during and after decay. So before decay, you had 53 protons and 78 neutrons. That gave you a relative atomic mass of 131. After decay, you increased the number of protons by 1 to 54 protons, but you decreased the number of neutrons to 77. So 54 protons plus 77 neutrons is still a relative atomic mass of 131. So remember, iodine had 53 protons. We now have an element with 54 protons. The element on the periodic table with 54 protons is xenon. So what is the relative atomic mass and the atomic number of xenon? Well, remember, the relative atomic mass before and after decay does not change, so the top number remains the same at 131. However, the bottom number does change, because after decay, we've got one more proton in the nucleus of the atom. So that means we've got 54 protons. So xenon has got 54 protons. So this isotope of xenon has got 54 protons and a relative atomic mass of 131. And then don't forget to show the beta particle being emitted. The beta symbol, a 0 on the top and a -1 on the bottom. And this electron is emitted as a beta particle. So a beta particle is an electron. It's question time. Attempt these questions to check your understanding. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes. Visit KayScience.com for more free videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.